And clearly in this case, okay, the 2 mass has an advantage because it has more mass on less surface. That is, if I'd made the 2 mass out of 2 1s,
which it is,
one can figure that, oh, well, that's twice the surface area, twice the contact with the ground. So it's, much more contact with the ground. So he should have done it, the experiment, with the same surface area per mass contact with the ground. And then the results would have been more predictably 2. Probably something like 1.8 because of these other flaws. But clearly, the 2 mass went further than it should have, merely because it was taking advantage of the fact that it was making less contact with the ground.
Right, we can test that out then, can't we?
Per unit of mass, it had the same surface area hitting the ground. It's pretty clear. So I guess I would just say, what would your predictions be? Okay.
Don't need to do a prediction. I can do the test.
Do thems. What is your prediction? Do you think you're going to get 1.4 if you have the same surface area contact with the ground proportional to the mass? So if the contact is proportional to the mass, do you actually think you're going to get the same results?
Pretty much, yeah.
I think
So just to verify the masses and the new configuration. 75.2. 75.2 for the 1 mass, and the half mass is 36.75. Again, 36.75 in grams. Obviously, this being the center to the center, and then obviously when we put the half mass on, we're measuring from the center of that, so all the measurements, are adjusted for start position to finish position.
I can finish that build. Game over. Sorry, Sandon has said. I know gold. Mama Ginger. I can make Ginger. Bye, Ginger. Let's try again. What's your favorite, Ginger?
So roughly measuring from its centre, obviously, because we've got 2 now flat next to each other. So from the centre point, we achieved a 33.5 and a 37 centimetres, so minimum 33.5, maximum 37. I think when I did it before it was 33 and 37.5, so it's made little to no difference doing it that way. So we'll do his predictions. So from the measurements there we can predict his KE and roughly where they'll be, but obviously when we're launching this one the centre of mass is further back now, so that was where the one mass was and that's where its centre of mass travelled to. Now we're measuring from the centre of mass of this launch one, which is a half mass. His measurements are very similar to before, so yeah, 46.6 and 52.3. Not exact, but you know, thereabouts. Obviously it's not going up here, is it? Well, we'd just like to introduce my little helper today, car, Gromit, Ace. So as we can see again, well within the range. That range was 33.5 to 37. This range we predicted, but the actual range is 47.5 to 51.6. So I've taken an average of the 10 of the readings for the full mass and averaged them out, and that comes out at 35.49. And then 10 readings for the half mass, and that averages out at 49.395. So if we round them up to the one mass at 35.5 and the half mass at 49.4, we divide 49.4 by 35.5 and the ratio is 1.391.